Hello, I hope you're all doing well. In this video, I'm going to discuss about states of matter, and this video is going to be useful for students of both certificates, O levels and IGCSE, because as you can see that this syllabus content is exactly similar. So in this video, we will discuss properties of different states of matter, their structure, how these different states will change into each other, and the effect of temperature and pressure on the volume of gas and heating and cooling curve. And after that, at the end of this video, we will discuss diffusion, which is very important part of this topic. Okay, so firstly, we are going to discuss properties of different states of matter. Now, as we know already that what is matter, that matter is anything which occupy some space and have some mass. So as you know that everything will have some mass except few, like space is not a matter because it does not have any mass. Otherwise, your pencil, your register, your like anything, it could be very small or large, it will have some mass and it will occupy space. So everything around us is matter. Now matter will exist in different states, and one of them is solid, then liquid and gas, and one more state is also present, that is plasma, but that is not in our syllabus. So how we can differentiate these three states of matter with respect to their properties? So first of all, volume. Now solid will always have fixed volume. Your pencil, your ballpoint, your tablet or cell phone, these all will have fixed volume. If you will place your like mobile on anywhere in your room or in your surrounding, its volume will remain fixed. And liquid, like water, it will have fixed volume. If you will transfer a liquid from this container to this container, its volume will remain same. If it is 10 centimeter cube in this container, it will remain 10 centimeter cube in any other container. So the volume of a liquid will remain fixed, but this is not the case with the gases. If you will transfer a gas from a very tiny jar into a larger jar, that the volume of gas will become the volume of that jar, that larger jar. So if you, let's suppose, if you transfer a gas from this small container into comparatively a larger container, the volume of gas will become equal to the volume of this container. So basically the volume of gas is actually the volume of container. So if you will place it in any container, its volume will become the volume of that, like the volume of that container, it will become equal to the volume of that gas. So volume of gas is not fixed, it depends on the volume of container. Then the shapes, solid have fixed shape. Your pencil will remain the shape which it has right now if you will place it anywhere. And the shape of liquid will change. If you will transfer this liquid from this container to this container, its volume is remain same, it will remain 10 centimeter cube, but its shape will become similar or same as the shape of this container is. So the shape of a liquid would be the shape of a container, and this is similar with the with gases. Like if you will transfer a gas from balloon into a rectangular shaped container, the volume of gas will become the volume of that the shape of the gas will become rectangular. So if you will transfer a gas from rectangular to any other shaped container, its shape will become similar to the shape of that container. So the volume of gas depends upon, and the shape of the gas depends upon the shape of container, and similar for gases and liquids, but not for the solid, it will remain fixed. Density of solid is highest, then the lower is for liquid, and the lowest is for gases. Density, what is density? We know that it is mass per unit volume. So as you can see that these particles are much more denser. So in this small area, in this small volume, small container, if you will have all these three states in a similar container, then you can see that the particles are much more closer and denser in that particular volume in the case of solids. And for liquid, these are less denser, like less number of particles or less mass is present in that particular volume. So it's mean that the density is becoming low, and as you can see for gases, their density is much more lesser than these two states. So arrangement of particles, how particles are arranged, as you can see here in these diagrams, that particles in solids are closely packed in a regular pattern. This is the arrangement of particles in solid state. And for liquid, the particles are randomly arranged, and for gases, the particles are much more randomly arranged. There are large spaces between particles, so these can actually move around. So motion of particles, solids particles, as you can see that there is not much space between these particles, so one particle like this particle cannot move from here to this corner of the container. So it is it will remain at its position, but still it can vibrate. Vibration is to and fro motion, so it can vibrate or rotate clockwise or anti-clockwise, but it cannot move from one place to another. So vibration and rotation, and keep it in mind that every particle, irrespective of any state, it will always move. So if it is solid, the particles of solid will move, and particles of liquid or gases, every particle will move. We will discuss one theory about this point also. So motion of particles, particles will move in and rotate in solid state. Then in liquid state, these can also move from one point to another. So liquid particles can slide over each other, and these can travel from one place to another. And same for gases. Gaseous particles can move freely in anywhere in that container. Then kinetic energy of particles, it's very low. Particles are very close to each other. These cannot move from one place to another, and the energy that is linked with the motion is called kinetic energy. I think you're all familiar with this term, kinetic energy. That part, if something is moving fastly, it's mean that its kinetic energy is high. So solid particles cannot move very fastly, so that's why their kinetic energy is very low. And liquid particles can move little bit as compared to solid, so this can their kinetic energy is, as compared to solids, their kinetic energy is high, and but lower than gases. So that's why I have written here it's low as compared to gases, but higher as compared to solid. And the particles of gas can have very high kinetic energy. That is why this can move very quickly in that container. Then attractive forces between particles. Solid, this is very important point, why these all particles are present in different states. The main thing is that the difference is in their between their attractive forces between these particles. So the strength of force of attraction between these particles is different. That is why, like, these particles are closely attached, because the forces of attraction are very strong between these particles. And in this state, particles are comparatively away, they can move around, their forces of attraction are comparatively weaker. And as you can guess easily, that in this phase, in this state of matter, the forces of attraction are very weak. So you can see that the forces of attraction in particles of solids are very strong, then strong for liquid as compared to gases, and in gases the forces are very weak. And these few points are it seems that these are very simple, we can understand them easily, and it is right, but these points are very important to justify the physical properties of different materials. So we will use these properties in our next topics also, like in bonding part as well. Then kinetic theory of matter, as I have just discussed it that the particle, irrespective of its state, it will always move. And this theory is kinetic theory of matter, that all matter is made up of particles which are in constant motion. So solid state particles were vibrating and rotating, and liquid were freely moving, and gaseous particles were also moving. So all particles are are always in motion. This is kinetic theory of matter, and according to that we can explain that how state will change, like how solid can convert into liquid and liquid can convert into gas. So we can discuss this conversion according to this theory. So how we can discuss that? So solid particles, because their forces of attraction are very strong, their kinetic energy is low. So solid particles have, maybe we can write supposed value. Let's suppose solid particles are having 40 energy, kinetic energy, and the particles of liquid are having 50 kinetic energy, and particles of gaseous, as we have just studied that their kinetic energy is highest, so we are just writing this supposed value. So if you want to convert solid into liquid, then you have to provide energy to solid so the particles of solid can move just like a liquid, just like particles in liquid state. So if you want to increase the energy of this solid, these solid particles, you have to provide energy, right? So we can provide energy in the form of heat. So we will provide energy in the form of heat. That heat energy will convert into kinetic energy. Particles will move faster, and once this energy will convert into kinetic energy, now particles are moving faster and this will move apart, and there will be gaps between particles, and the arrangement of particles will become random, and that state is called liquid state. And if you want to convert liquid into gas, then you have to provide more energy. Like if the energy of liquid is 50, and if you want to convert that liquid into gaseous state, then you have to increase the kinetic energy of particles of liquid up to 60 degrees centigrade, or 60, whatever that number is. So you have to again heat this liquid particle, then particles will gain energy, and that energy will convert into, that heat energy will convert into kinetic energy, and then particles will move around much more fastly, and that is why these particles are now in gaseous state. And what you will do if you want to convert gas into liquid, or gas into, or liquid into solid, then definitely you should lower the energy of the particles of gas. And how that will occur, how that can happen easily, you can just do that by cooling effect. So if you will cool it, the gaseous particles, the energy will release, and that energy will release in the form of heat and into the surrounding. So when you will lower their energy, these gaseous particles will convert into liquid, and if you will further lower the energy, these liquid particles will convert into solid state. Now we have some names that we have just given to these processes, these steps of conversion, that if you will convert solid particle into liquid, this process is called melting, and the temperature at which this process will occur, that temperature is fixed. So different substances will have different temperature, a fixed temperature at which these will convert from solid to liquid, and that temperature is called melting point. And if you want to convert liquid into gas, this process is called boiling, and the temperature at which this process will occur, that temperature is called boiling point. And if you want to convert gas into liquid, then that process is called condensation. I know these are all very basic things. You have already learned these things in your middle or primary classes, but this is what it is. So we are just revising that concept, those easy processes. So if you want to convert gas into liquid, this is called condensation. And further, if you will further cool down this liquid, that will convert into solid, and this process is called freezing. And the temperature at which condensation will occur, that temperature would be condensation point, and the temperature at which the liquid will freeze into solid, that temperature would be our freezing point. So we are familiar with all of these, and we have just revised those. You can use the example of water, like the temperature. What is the boiling point of water? What is the boiling point of water? 100 degrees centigrade. So 100 degrees centigrade is the temperature at which water will convert into steam or gas. And what is the freezing point of water? Freezing point of water is 0 degrees centigrade. And you should know that the melting point and freezing point, these are always same. So if anything is melting at 0 degrees centigrade, it will freeze. If you will just lower the temperature at 0 degrees centigrade, then that substance will freeze at that temperature. So at 0 degrees centigrade, when you will increase temperature from 0 to maybe 1 degree centigrade, the liquid will the ice will melt. And if you will lower the temperature from 0 to maybe -1 degree centigrade, that temperature would be at which the liquid water will freeze. So 0 degree centigrade, it is the point at which these both processes can occur. You can freeze or you can melt your substance just by slight change in their temperature. And this is similar in the case of boiling point and condensation point. So condensation point and boiling point are similar. If you want to convert liquid into gas, like water into liquid water into gas, you have to provide 100 degrees centigrade. And if you will just lower the temperature from 100 to 99, at that exact temperature, the gaseous steam or gaseous water molecules will condense back into liquid. So 100 degrees centigrade is the boiling and freezing condensation point of water. Now this is very important, that as we have just studied that boiling is the conversion of liquid into gas, and there is another term which is evaporation, and this is also process at which you can convert liquid into gas. So both of these processes are similar. Like boiling is conversion of liquid into gas, and the same for evaporation, but with few differences. Boiling will occur at fixed temperature. Like if you want to boil something, you have to heat that substance at fixed temperature. There is a temperature you should attain to boil something. So 100 degrees centigrade was the temperature at which you can boil your liquid. So this will occur at fixed temperature, and that is why you have to provide energy by heating that liquid. But in evaporation, this process can occur at any temperature lower than 100 degrees centigrade. You can evaporate your liquid at 10 degrees centigrade, 15 degree, 50 degree, 60 degree. You can evaporate your liquid at any state, at any temperature. And how that will occur, that let's suppose these particles which are directly facing the atmosphere, these particles will absorb energy from the surrounding, and these particles, by absorbing energy, these particles will easily convert into, these will detach from the particles which are present under these particles. So these will easily convert into gaseous states. And these surface the particles on this surface, these will have highest energy, and it is very easy for us to evaporate, to detach these particles, and to convert them into gaseous state. So by just absorbing heat from surrounding, or if you will provide a very small amount of heat to this liquid, these higher energetic particles will absorb energy, and these will detach from these particles, and that is why these will easily convert into gaseous state. So this is evaporation. So how we can differentiate that? Boiling will occur throughout the liquid. If you are heating this substance, every particle will absorb energy equally. So every particle can boil. That is why, like, if this particle will boil, it will convert into gas, it will come upward, and you will observe that there is the formation of bubble, which is definitely a gas. So it's mean that the liquid particle that was present under the surface of that liquid, that liquid particle is basically converted into gas, and now it is becoming upward, and then at the surface you will observe a bubble. So this is boiling. It will occur throughout the liquid, but evaporation will occur only at the surface of the liquid, only at the surface of the liquid, and at fixed temperature. Boiling will occur at fixed temperature, as we have just discussed, 100 degrees centigrade. But for evaporation, once these particles will just absorb enough energy, these will evaporate. So there is no need to provide that high temperature or fixed heat or temperature. So you can simply heat this liquid at any temperature. So that is why there is no need to have fixed temperature for evaporation. And boiling is a fast process. As you are heating it at higher temperature, 100 degrees centigrade, and you're using a flame or any other source to heat this liquid, so it will occur, this process of conversion of liquid into gas, this will occur very fastly. And evaporation, this is comparatively a slow process, and that is why these three differences you should know that the boiling and evaporation have. So if you will be asked these questions, you can write these 3 points, that it will occur throughout the liquid, it will occur at fixed temperature, and the boiling is fast and opposite for evaporation. Now in our next video we will discuss that what are these heating and cooling curve. Thank you so much.